Today our goal is to think about what force is, and what that means is that we're going to be thinking about Newton's first law of motion. If you've heard of his 3 laws of motion, we're going to be thinking about this first one. Later in the term we will also be thinking about his 3rd law of motion. For every action there's an equal and opposite reaction, and we will not be thinking about the 2nd law of motion, force equals mass times acceleration. If you take a physics class, you might think about that one. But let's think about this first law of motion. So it says a body at rest will remain at rest, like this coach is, until acted upon by an outside force. Outside force is the key. Force is outside stuff, it's external stuff, and it's one body acting on another body. So it might be you pushing or pulling on a door. Maybe you've got a chair with rollers on it and you push on that. Your body is acting on the chair. And it's a push or a pull. That's it. And in the US system, we measure it in pounds, force in pounds. We'll look at a few metric problems, but mostly we'll stay in US. And this action can be the things touching each other, but it can also be just due to gravity or magnetism, where the objects don't touch each other. So here are the 3 basic ideas of force. If a little kid next door called out of their window to you, "Hey, what is force?" This is what you could say, and you would have summed it all up. It's a push or a pull, it's external, and it's measured in pounds. You'll recall that load is another name for force, so there are 3 ways that load can happen on a body. It can be concentrated. For example, you might have a column sitting on top of a beam. That's a concentrated load. It might be distributed. So, for example, you might have a concrete slab resting on some beams. That's distributed. It could be varying, and we're not going to deal with these kinds of loads. We'll just deal with concentrated and distributed. Okay, so force, push or pull, there are only 2 kinds of forces, and that's it. That's all you have to deal with. Push or pull. And a fancy way of saying push is compression. A fancy way of saying pull is tension. And if you have a rubber band at home and a sponge at home, it would be a good idea to pull on that rubber band and just feel what tension feels like, and then push on that sponge and see what compression feels like. Or another good thing I recommend you do is find a door wherever you live, and first, with the door closed, push against it. Even though the door is closed, just push as hard as you can, and you will feel what compression feels like. And then, with the door latched so it won't pop open on you, pull on that door as hard as you can. That will tell you what tension feels like, and you'll feel that tension in your arm and your shoulder probably. That's that pulling force. So that lets you feel what your structure or your truss or your beam is feeling when it's experiencing compression or tension. And so we'll see all kinds of structural members that experience compression or tension. Arches are 100% compression. That's how they do their work. The Romans discovered this and made great use of it. Cables are 100% in tension, and that's how they do their work. Now, when you draw a picture of a force, you draw an arrow. And the reason we do that is because a force is what is called a vector quantity. That means it's a quantity that not only has a size, we call that magnitude, it's also got a direction. So that's different from what you call a scalar quantity. Scalar is a counting thing, a number thing. So you could say, I have 5 marbles. That's a scalar quantity. Or you could say, this thing is 12 inches long. But if you have a force, you have not only a size, you might say this thing is pushing with 20 pounds of force, but it also has a direction. It's going at a certain angle, and it's going to have a different effect if it comes in at a different angle. And this leads us to thinking about the characteristics of a force. And what we're seeing here is a small motorboat. It's feeling some force from the current of a river pushing it sideways. Oops, sorry. And it's also feeling some force from the motor pushing straight across. We'll come back to this boat next time. So those arrows are pictures of the forces acting on that boat. And as you might notice, it makes a difference where that force gets applied on that boat. So one of the characteristics is point of application. Where do you apply that force? Or think about pushing on your chair that's on rollers. If you push on one side of the chair, you're going to get a different effect than if you push off to the side of the chair or someplace completely out in space. So it matters where you start. But what we'll especially be thinking about this term is the other two characteristics: magnitude, how big is the force? Is it 20 pounds of push? Is it 10 pounds of push? And the direction. And the direction is made up of two elements. There's the angle, so is that at a 60-degree angle or a 45-degree angle? And the sense. Sense is represented by what direction that arrow is pointing. Is it pulling away or is it pushing towards, for example? So here's kind of a diagram of those, in addition to point of application, those other two characteristics: magnitude, how big is it, and direction, which is made up of what angle is it, and what sense is it, what direction is your arrow pointing. Now, when you draw a picture of a force, here's what you do. Well, you look at what angle the force is pointing and you draw your arrow that direction, but then you make the length of your arrow match the magnitude of the force. So if you have a 500-pound force pulling straight up, you draw an arrow 500 units long straight up. If you have a force of 1,200 pounds pulling sideways, you draw an arrow 1,200 units long pulling sideways. And if you think that force is pulling, if you think it's in tension, then you make your arrow point away. And if you think your force is pushing, if you think it's compression, then you make your arrow point towards. That's how you tell what direction those arrows go. Now, a couple of principles that are kind of important when you're drawing pictures of arrows. One of them is, for all practical purposes, it doesn't matter how long your rope or your cable or whatever is. Your line of action that the force is acting on can be any length. Now, I know in the real world, rope is stretchy and so forth, but in the world of statics, where we pretend everything is rigid, that line of action can be any length you want. A short rope or a long rope has the same effect. And another important principle for you is the principle of transmissibility, and it says you can slide your force anywhere along that line of action as long as it's the same magnitude going the same direction. You can have a different point of application and it's going to have the same effect. So what we mean by that, or to illustrate that, I guess, here is a person maybe in a warehouse pushing on a pallet on some wheels. And let's say they push with 20 pounds of compression. Here's another person with a pallet just like that. They are pulling with, what did I say, 20 pounds, 50 pounds, whatever that force was. They're pulling with that same magnitude of force. That pallet is going to roll the same direction, the same speed, no matter whether the person is pushing with that amount of force or whether another person is pulling with that amount of force. So what that means for you is if you're drawing a picture of forces with some arrows and it's not handy for you to have the arrow over here, you can just slide it to the other side and it has the same exact effect. Here's another example. Here's a weight sitting on top of a table, weighs 180 pounds. And down below that is a picture of that force. See that arrow? That force is on top of that table. These other arrows, by the way, are the holding up forces of the legs. Well, you could have the same effect on that tabletop if you hung that weight from underneath the table. So here at the bottom is a diagram of that force coming off the bottom of the table. Same effect. So that's the principle of transmissibility. You can slide a force anywhere along the line of action and you get the same effect. So last two slides, let's just review what we know about force. First of all, force is pretty simple. Force is just a push or a pull. That's it. It's external stuff, so you're pushing on the outside of a thing or you're pulling on the outside of a thing. And in the US system, it's measured in pounds. That's it. And the three characteristics of a force are point of application, where is it, magnitude, how many pounds is it, and direction, how many degrees is the angle, and what sense is it? Is it pushing towards or pulling away? What direction is your arrow pointing? Let me look at those one more time. Force is push or pull, it's external, and it's measured in pounds. And the three characteristics of a force, because it's a vector, point of application, magnitude, and direction. And direction is made up of angle and sense. There you go. You now can answer questions from anybody who comes up to you and asks you about force. That's all there is to it. Now we'll just start using that to draw some arrows.